Hello, let's do one up, puzzle 178 for September 14th. Let's go. So I'm going to explain the rules real quick. In each row and column, they've been split up into segments by these bold borders. So this is a segment, this is a segment. Some of the rows and columns are just a single segment. They don't have any borders splitting them. Now a segment has the digits 1 through n, where n is the length of the segment. And we're putting them once each. So every digit from 1 through n is placed. So we need all of 1 through 4 placed in this segment and all of 1 through 4 in this segment. This segment here is 8 long, so is this one. We need 1 through 8, exactly once each in those. All right, I'm going to get started. I noticed we have some given ones here. So this is a 1 because it's in a segment of length 1, and this is a 1. That makes this a 2 and a 1. Oops, sorry. Sorry, this is a 2 and a 1 because of this one. For some reason I thought this one affected it, but there's a border there. I don't know why I did that. But this one does make that 2 and 1. Okay. Silly mistake to make this far in. All right, this needs 1 and 3. This can't be the 1. So this is 3 and 1. This segment needs a 1. There's a 1 here and a 1 here. So we can get a 1 here. I wonder if we can like place all the 1s. So every segment needs a 1. Let's look at ones that are restricted. This segment can't have a 1 here or here, so it goes there. We're left with 2 and 3. This 2 gives us the 3 and the 2. That time was just a typo. That's a 4. This segment needs a 1, but there are plenty of places for it. Let's just do the columns first. That has a 1, that has a 1, that has 1. This segment needs a 1. Can only go here. This segment has a 1. This segment needs a 1. That has a 1. It could be here. Okay, so it's in one of 2 places. This needs... Okay, this is 2 and 1. Ugh, I did that. Oh, there is... Ah, I see what I did wrong. Sorry, let's do this first. This is 2 and 1 because of this one. I thought that this one would... Wow, I'm doing cross-border scanning too much. I need to be more careful. But this is the one. It can't be here or here or here. Sorry about that. Good thing that was a mistake, because then it would have been a lucky mistake, and I hate those. I much prefer to make a mistake that actually is wrong, because then I can go back and correct it. Okay. Here we need a 2. Okay, this 2 does not go across the border. Be careful. Okay, we're continuing to look at ones. This can't be 1 because of that. This can't be 1. This can't be 1. This can't be 1. So the 1 for this segment goes down here. And this segment needs a 1. Not there, not there. It ends up right here. Okay, I think we have all the 1s. If every vertical segment has a 1, then that means every horizontal segment has a 1 as well. We don't have to check. Okay, this segment needs a 1. It can't be there. There should be just one more to place. Yeah, it's exactly right here. It can't be here or here because of these ones, and there is no segment in this between those. All the 1s are done. We could look at 2s. I don't know if we're gonna... We don't have as many 2s placed, but we can try. Here we need 2, 4. Oh, okay, so this can't be the 4 because this is a 3-length segment. So this is the 2 and this is the 4, and that makes this a 3 to finish that segment. So, vertical segments need a 2. This can't be 2. This could be. Ah, but horizontally we need a 2. This 2 sees here, this 2 sees here. So that's our 2. This is 3 and 4. This 3 tells us that's 4 and 3. Okay, here we need 3 and 4. Can't resolve that. Okay, we need a 2 in this segment. Plenty of places for that. This segment has a 2, this segment has a 2. This segment needs a 2. There are 2 places for a 2. This segment can have a 2 anywhere. Yeah, this isn't looking good for 2s. Let's see, we need 4, 5, 6 here. Ooh, wait. Yes, okay. This maxes out at 4. It can't be 1, 2, or 3, so it has to be a 4. It maxes out at 4 because of this row. So now we're left with 2, 3. This can't be the 3. So that's 2, that's 3. Okay, that's working out well. So this can be 2, this can be 2. Here we need 5 and 6. I don't think we can resolve that. What do we need here? We have 1, 2, 3, 4. We need 5, 6, 7, 8. I wonder if we can do 8s now. We can definitely do the 8 in this column. Can't be here, it can't be here. This row is not 8 long. So the 8 can only go there. Let's actually look at what columns need an 8. This has an 8, this has an 8, this has an 8. Honestly, I think we just finished the 8s by placing a single 1 because we were already 2 placed. Maybe I can look at 7s next. This column has a segment. This column, sorry, this segment has a 7. This segment here, that can't be 7, that can't be 7. The 7 is going to be here or here. I'm going to mark, I'm going to try to avoid marking if I can, but I would normally just mark the 7s in these two spots. But let's see how 7s are restricted. We can't have 7s there, there. This segment here needs a 7. It could be here or okay. So this segment needs a 7. Can't be here. Can't be here because this is 6 long, so it has to be here. And that was one of the places this needed a 7 from, so the 7 ends up from there. And now we have finished the 7s. Just double checking. Every 7 long segment has a 7. Yeah, 7 or 8 long. This is 5, 6. This could be a 6 because it is 6 long. So we don't know how the 5, 6 resolves. This is also 5, 6. We don't know how that resolves. We need a 2 in this segment here. Can't be here or here because of this 2 and this 2. It could be here. It could be here. Can't be there. So there's 2 places for 2. What about 3? 3 is in here or here. And then 4? We know this is 2, 3, 4, by the way, because I know that 5, 6 end up over here. So this is 2, 3, 4. But I don't think it resolves, unfortunately. Let's see. We need a 2, 3, 4 in this column. That's not resolved. I may have to start penciling. I hope I feel like I can get a little bit more. Maybe I'll keep working backwards with 6s. I'm not sure. This can't be 6. The 6 would be here, here, or here. There's a lot of places for 6. 6 could be here, here, or here. Not here. Here or here. This column needs a 6. There's so many places for 6. This we need 2, 4, 5. Okay. I don't think 6s are helpful. Maybe there's a row that needs a 6 that's limited. One of these two. Hold on. No, this can be 6. All right, I'm trying to see if there's anything I can do before I resort to penciling. Was about 3s in rows and columns? We need a 3 in one of these two. We need a 3. Yeah, there's just not that much to do with 3s. Lots of places for 3s in all these segments. This segment needs a 3. It can't be here or here. This 3 and this 3. So this is the 3 for this segment. And we're left with 2, 4. This 2 tells us this is 4, this is 2. Okay. Found something. We have 1, 2, 3, 4. We need 5, 6 across here. Okay. We have a lot of 5, 6s that we haven't placed. These are 5, 6, all of these. And then now these two are 5, 6. What do we need here? 1, 2, 3, 4. We need 5, 6, 7. This can't be a 7 because this is 6 long. And this can't be a 7 because of that 7. So the 7 in this segment here actually is placed. It's right here. Okay, and so now this is also a 5, 6 pair. So if we were penciling it, we'd have 5, 6 here, 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 and 5, 6 here. So those are connected. Can I resolve them in some way? Would be amazing. Here we need 2, 4, 5. Unfortunately, oh wait, no, the 2 can be placed. This 2 and this 2. So that's our 2, and we're left with 4, 5 across here. We're 3, 4 across here, 4, 5 across here. I'm seeing that 4 ends up in this square, twice in this square. I've explained this before, but without penciling, it actually is really hard to explain. But this row needs a 4 and this row needs a 4. That's 2 4s in this little square here. They're either going to end up in this diagonal or this diagonal, because they can't repeat in a row or column. Either way, it removes 4 from the rest of these columns, because the 4 is going to be like this, or here, I'll write it out. The 4 is going to be like that, or the 4 is going to be like that. Those are the only two options, because both of these rows need a 4. And that removes the 4 from the rest of these. So this can't be 4, this can't be 4. I don't think that's enough to do anything with. Either of these can be 4. Yeah. What about up here? Either of these can be 4. Okay. So what am I missing here? I just got this 2, I believe. Should we look at 2s some more? We need a 2 here. One of these 2. We need a 2 here. Also one of these 2. That's the only 2s left. Just this sort of rectangle of 2s. Again, they'll be in the diagonals. Do I move on to 3 then? Yes, we need a 3 in this column. Can't be here or here. So that's a 3. We are left with 5, 6 again. So many 5, 6s. Let's keep doing 3s here. This could be 3 or this. So this column does not have the 3 placed. The 3 here, here or here. 3 here is here or here. Everything else has a 3. I don't think 3s can be finished right now. All these 5, 6s. I guess we could look at 4s then. This column needs a 4. Could be here, could be here. This is 4, 5. Ah, darn. I really don't want a pencil, but I think I might have to. There's something subtle here. Let's just look at these columns. We need 3, 4, 5, 6 here. This is 5, 6. Another 5, 6. Because it can't be 3, 4. Oh, okay. Well, no, this is 4, 5. 3, 4. This is 3, 4. No, we already knew that. 6 isn't any of these 2. We need 2, 3, 4 here. Doesn't help. We need 2, 4, 5 here. Wow. Yeah. Well, we know these aren't 5 or 6 because the 5, 6 is here. So these are 2, 3, 4. This is 3 or 4. And this is 3 or 4. Okay, I think I found a pair here. If I was penciling, it would be much easier to show you. So the question is, where do 5 and 6 go in this column? And I will say this can't be a 6, because if you remember, this has to be a 5 or 6, and this has to be a 5 or 6. And so if I was penciling, I'd pencil 5, 6 here and 5, 6 here. Basically, if this ends up a 5, this must be a 6. If this ends up a 6, this must be a 5, because the columns only have 5, 6 left. So therefore, the rest of this row is not 5, 6. So if this is not 5 or 6, especially not 6, where does 6 go in the column? Because it's not here. And then these are too short to be 6, because this is 5 long and this is 4 long. So the 6 ends up here. And then that makes this the, no, sorry, I thought for some reason I thought it would be 5, 6, but it's not 5, 6. So the question is, where does 5 go now? Because it can't be here for the same reason, the 5, 6 pair that's there. So this has to be the 5, because this is only 4 long. So now we're left with 3, 4. Oh, but this row finishes with a 4. And so now this is 3, 4. This has to be the 3 and the 4 because of the 4 there. Nice, okay. So this is a 5. This is a 6. This is a 5. And we get the 6, 5, and 6. In my head, those are penciled. And that makes this the 3 for the column. This column, we have 1, 2, 3, 4. We need 5, 6 here. This 6 tells us the order. That's 5 and 6. So we just got a nice cascade of all the 5, 6s finishing. What do we need here? We need 2 and 4. This, no. There's that 2, doesn't see it. 2 and 4 are left here. What about here? We have 1. We need 2 and 5, and this is 4 long. So this is the 5, this is the 2, which makes this the 4 and the 2. And then our last digits here are 3, and then 1, 2, 3, 4. Solved. All right. 14 minutes, 19 seconds. Well, took a while, but yeah, managed to do it without penciling. I kind of penciled in my head, which I guess is fair. This is one of the reasons I don't like doing no penciling in these videos, is because it's really hard to show my head without penciling it on the screen. But yeah, the key, I think the key step here was this 5, 6 pair, removing 6 from here, placing the 6 in this column. I think that this 5, 6 pair was necessary to solve the puzzle. So cool. Well, hope you enjoyed it, and how'd you do?